So the original golden record is, I like to think of it as sort of a time capsule of humanity that was designed to represent us, who we are as a species, what we love, why we love it, what we do, and sort of our diversity, why we're all different, why we do different things, to possible extraterrestrials. And so the golden record was produced in 1977 by a relatively small team led by Carl Sagan. What we're doing, my team, is we're working on creating an updated golden record. And I began researching different storage methods, and I began to realize that we hadn't made that much headway in storage since then. Of course, we've made progress, but nothing really spectacular until I found 5D storage. And I noticed that there were only two real places that I could find information about this. One was the University of Southampton, and one was Project Silica at Microsoft. I reached out to the University of Southampton and Dr. Black, and somehow, kind of to my surprise, Dr. Black actually responded.
I was particularly intrigued by the Avenues Golden Record application because I could see it was an application not just where Silica was a better media than what people use today, but really where Silica was the only media that would work, because none of the standard media really work over the kind of timescales that are involved in space travel, and none of them really work in the harsh environments that are involved in space and outer space and space travel. So in some ways, for me, it was an easy way to communicate just what a transformative digital media technology Silica is. And that's why as an application, it really grabbed my interest.
You're listening to Collaborators, a Microsoft research podcast showcasing the range of expertise that goes into transforming mind-blowing ideas into world-changing technologies. I'm Dr. Gretchen Huizenga. Today I'm talking to Dr. Richard Black, a senior principal research manager and the research director of Project Silica at Microsoft Research. And with him is Dexter Greene, a rising freshman at the University of Michigan and a recent graduate of Avenues The World School in New York City. Richard and Dexter are involved in a unique, multidisciplinary, multi-institutional, and multi-generational collaboration called Avenues Golden Record, a current effort to communicate with extraterrestrial intelligence. We'll get into that in a lot more detail shortly, but first let's meet our collaborators. Richard, let's start with you. As I've just noted, you're a research manager at the Cambridge UK lab of Microsoft Research and the research director of a really cool technology called Silica. In a second, I want you to talk about that more specifically, but right now, tell us about yourself. What's your background? What are your research interests writ large? And what excites you about the broad remit of your work at Cambridge?
So, my background is a computer scientist. I've been at Microsoft Research for 24 years, and before that I had a faculty position at a university here in the UK. So I also have an interest in education, and it's been a delight to interact with Dexter and the other students at Avenues. My interests, research interests, really cover all aspects of computer systems, which means operating systems, networking, and computer architecture. And the exciting thing for me about being at Microsoft Research is that this is really a period of rapid change with the cloud, digital transformation of society. It gives really a huge motivation to research better underlying technologies for everything that we do. And for me, in the last 2 years, that's been in archival storage with Project Silica.
Richard, I'm interested to know a little bit more about your background. Where did you go to school? What led you to this kind of research? And what university were you teaching at?
Yeah, I went to university, did my PhD here in Cambridge. I was teaching at the University of Glasgow, which is in Scotland in the UK, and teaching, again, computer systems, so those operating systems, computer architecture, and computer networking.
Well, Dexter, you're the first student collaborator we've featured on this show, which is super fun. Tell us about yourself and about Avenues The World School, where this particular collaboration was born.
Thanks for having me. I'm super excited to be here. And like you said, it's very cool to be the first student collaborator that you featured on the show. So I'm 18. I just graduated high school a few months ago, and I will be attending the University of Michigan's College of Engineering in the fall. If you know me personally, you know that I love robotics. I competed in the First Tech Challenge all throughout high school. The First Tech Challenge is a student robotics competition. There's the First Tech Challenge first robotics competition and first Lego League. So it's like 3 different levels of robotics competition, which is run all around the world. And every year there's like a championship at the end to declare a winner. And I plan to major in either robotics or mechanical engineering. So more about Avenues. Avenues is a K through 12 international immersion school, which is very interesting. So younger students might do a day in Spanish and a day in English, or a day in Mandarin and then a day in English, going through all their classes in that language. So when I actually attended Avenues since 2nd grade. So when I was younger, I would do a full day in Spanish, and then I would switch to a full day in English, doing my courses like math, history, English, all in my language, Spanish for me. And Avenues is a very interesting school and very different in many ways. They like to sort of think outside the box. There's a lot of very unique classes, unique programs. A great example is what they call J term, or June and January term, which is where students will have one course every day for the entire month, where they can really dive deep into that subject. And I was actually lucky enough to do the golden record for a full month in 11th grade, which I'll talk about this more, but that's actually when I first made contact with Dr. Black and found this amazing technology, which is, I guess, why we're all here today.
Right.
So yeah, there's many really cool parts about Avenues. There's travel programs that you can do where you can go all around the world. You can go between different campuses. There's online classes that you can take. The list goes on.
Well, it's funny that you say when I first made contact with Dr. Black, because it sounds like something that you're working on. So let's talk about that for a second. So the project we're talking about today is Avenues Golden Record, but it's not the first golden record to exist. So for those of our listeners who don't know what golden record even is, Dexter, give us a little history lesson and chronicle the story from the original golden record way back in 1977, all the way to what you're doing today with the project.
Yeah, so I guess let me start with what is the golden record. So the original golden record is, I like to think of it as sort of a time capsule of humanity that was designed to represent us, who we are as a species, what we love, why we love it, what we do, and sort of our diversity, why we're all different, why we do different things, to possible extraterrestrials. And so the golden record was produced in 1977 by a relatively small team led by Carl Sagan, an American astronomer who was a professor at, I believe, Cornell. And so it's basically a series of meticulously curated content. So that could be images, audios, sounds of nature, music, the list goes on. Really anything you can think of. That's sort of the beauty of it. Mm-hmm. Anything can go on it. So it's just a compilation of what we are, who we are, and why we are, what's important to us. A great example, one of my favorite parts of the golden record, is one of the first audios on it is a greeting in 55 languages. It's sort of meant to be like a welcome, I guess less of a welcome, but more like a hello, because we're not welcoming anyone to Earth. But it's like a hello, nice to meet you, in 55 languages to show that we're very diverse, very different. Yeah. And yeah, you can actually, if you're interested and if you'd like to learn more, you can actually go see all the content that's on the golden records. NASA has a webpage for that.
Yeah.
I definitely recommend if you have a chance to check it out.
Yeah.
And I guess moving on to future attempts. So what we're doing, my team, is we're working on creating an updated golden record. So it's been 47 years now since the original golden record, kind of a long time. And of course, a lot's changed, some for the better, some for the worse. And we think that it's about time we update who we are, and what we care about, what we love.
Right.
So our team has begun working on that. One project that I'm familiar with, other than our own, that's sort of a similar attempt, is known as Humanity's Message to the Stars, which is led by Dr. Jonathan Jang, who is a researcher at NASA's Jet Propulsion Laboratory. Very cool. Yeah. That's the only project that's similar that I'm aware of, but I'm sure there have been other attempts in the past.
Yeah. Just to make a note right now, we're using the term record, and the original medium was actually a record, like an LP. But excitingly, we'll get to why Dr. Black is on the show today and talk about the new media. Before we do that, as I was preparing this episode, It began to feel like a story of contrasting couplets, like Earthlings and aliens, content and media, veteran researcher and high school student. So let's talk about the last pairing for a second, the two of you and how you got together on this project. It's a fun story. I like to call this question How I Met Your Mother. So how did a high school kid from New York come to be a research collaborator with a seasoned scientist from Cambridge? Dexter, tell your side of the story. It's cool. And then Richard can fill in the blanks from across the pond.
Yeah, so let me actually rewind a little bit farther than that about how I got into the project myself.
Good.
Which I think is a pretty fun story. So one of my teachers, my design and engineering teacher at the time, Mr. Cavalier, gave a presentation at one of our grade-wide assemblies. And the first slide was something along the lines of the most challenging project in human history, which immediately caught my eye. I was like, I have to do this. There's no way I'm not doing this project. And the slides to come, of course, made me want to partake in the project even more. But that first slide, really, I was sold. It was a done deal. So I applied to the project. I got in. And then we began working and researching. And I'll talk about this more later as well, but we sort of split up into two teams at the beginning, content and media being the form or medium that we sent it on. And so that was the team that I was on. And I began researching different storage methods and sort of advancements in storage methods since the original golden record in 1977. And I began to realize that we hadn't made that much headway in storage since then. Of course, we've made progress, but nothing really spectacular until I found 5D storage. And I was immediately just amazed by the longevity, durability, capacity, so many things. Yeah. I mean, there's just so many reasons to be amazed. But so I began researching, and I noticed that there were only two real places that I could find information about this. One was the University of Southampton, I believe, and one was Project Silica at Microsoft. And so I actually reached out to both. I reached out to the University of Southampton and Dr. Black, and somehow, kind of to my surprise, Dr. Black actually responded. And I was kind of stunned when he responded, because I was like, there's no way this researcher at Microsoft is going to respond to this high school student that he's never met in the middle of nowhere. Yeah. So when Dr. Black did respond, I was just amazed and so excited. And yeah, went from there. We began communicating back and forth. And then I believe we met once over the following summer. And now we're here.
Okay, there's so many parallels right now between this communication contact and what you're doing with potential extraterrestrial intelligence. It's like, I contacted him, he contacted me back, and then we started having a conversation. Yeah, so Richard, you were the guy who received the cold email from this high school student. What was your reaction, and how did you get interested in pursuing a relationship in terms of the science of this?
Yeah, so let me say I was really intrigued by the Avenues Golden Record application. I do get quite a lot of cold emails, and I try to reply to most of them. I do have a few canned answers because I don't have time to interact with everybody who reaches out to me. But I was particularly intrigued by the Avenues Golden Record application because I could see it was an application not just where Silica was a better media than what people use today, but really where Silica was the only media that would work, because none of the standard media really work over the kind of timescales that are involved in space travel, and none of them really work in the harsh environments that are involved in space and outer space and space travel. So in some ways, for me, it was an easy way to communicate just what a transformative digital media technology Silica is. And that's why as an application, it really grabbed my interest.
So did you have any idea when the initial exchange happened that this would turn into a full-blown project?
I didn't know how much time Dexter and his fellow students would have to invest in it. So for me at the beginning, I was just quite happy to answer a few questions that they have, to point them in the right direction, to fill in a few blanks and things like that. And it was only much later, I think, after perhaps we'd had our first meeting, that I realized that Dexter and his team were actually serious, and they had some time. They were going to actually invest in this and think it through. And so I was happy to work with them. and to continue to answer questions that they had, and to work towards actually, writing a couple of Silica platters with the output that they were creating and providing it for them.
Well, let's dig in there. Richard, let's talk about digital data and the storage mediums that love it. I want to break this into two parts because I'm interested in it from two angles. And the first one is purely technical. I'll take a second to note that we did an episode on Project Silica way back in 2019. I say way back, but in technical years right now, that seems like a long time. And on that episode, your colleague Ant Rostrin talked with me and Mark Rusinovich, the CTO of Microsoft's Azure. So we'll put a link in the show notes for that super fun, interesting show. But right now, Richard, would you give our listeners an overview of the current science of data on glass? What is Silica? How's it different from other storage media? And what's changed in the 5 years since I talked to Ant and Mark?
Sure. So Silica is an archival storage technology that stores data inside fused silica glass. And it does that using ultra-short laser pulses that make a permanent, detectable, and yet transparent modification to the glass crystal. So the data ends up as durable as the piece of glass itself.
Wow.
And being transparent means that we can get hundreds of layers of data inside a block of glass that's only 2 millimeters thin, making for really incredibly high densities. And since this new physics was discovered at the University of Southampton in the UK, we've been working to tame that, and we've improved density, energy over 100-fold in the time period that we've been working on it, and the speed over 10,000-fold. And we continue to, in our research, to make silica better and faster. And yes, you're right, 5 years might seem like quite a long time. A comparison that you might think of here is the history of the hard drive. In the history of the hard drive, there was a point in history at which humans discovered the physical effect of magnetism. And it took us actually quite a long time as a species to go from magnetism to hard drives. In this case, this new physical effect that was discovered at Southampton, a new physical effect, you can think of it a bit like discovering magnetism, and taking it all the way from there to actually a real operating storage system actually takes quite a lot of research and effort and development. And that's the path that we've been on, doing that taming and improving densities and speeds and energies and so on during the years of the project.
Well, talk a little bit more about the reading and writing of this medium. What's involved technically on how you get the data on and how you retrieve it?
Yeah, and so interestingly, the writing of the data and the reading of the data are actually completely different. So writing the data is done with an ultra-short laser pulse. It's actually a femtosecond length pulse. And a femtosecond is 1,000th of 1,000,000th of 1,000,000th of a second. And if you take even quite a small amount of energy and you compress it into time into a pulse that short, and then you use a lens to focus it in space into just a tiny point, then the intensity of the light at that point during that pulse is just so mind-bogglingly high that you actually get something called a plasma-induced nano-explosion. And I'm not an appropriate physicist of the right sort by background, but I can tell you that what that does is it really transforms the glass crystal at that point, but in a way in which it just is so short. The time pulse is so short, it doesn't really get to damage the crystal around that point. And that's what enables the data to be incredibly durable, because you've made this permanent, detectable, and yet transparent change to the glass crystal.
So that's writing. What about reading?
Reading you do with a microscope.
Oh my gosh.
And so it's a much more straightforward process. So a reader is basically a computer-controlled, high-speed, high-quality microscope. And you focus the microscope at an appropriate depth inside the glass, and then you just photograph it. And you get to, if it's an appropriate sort of microscope, you get to see the changes that you've made to the glass crystal. And then we process those images, in fact, using machine learning neural networks to turn it back into the data that we'd originally put into the glass platter. So reading and writing quite different. And on the reading, we're just using regular light. So the reading process can't possibly damage the data that's been stored inside the glass.
I imagine you wouldn't want to get your eye in the path of a femtosecond laser.
Yes, femtoseconds lasers are not for use at home. That's quite true. In fact, your joke comment about the eye is eye surgery is also actually done with femtosecond
Oh,
lasers.
okay, so
That's one of
maybe
the
you
other
would.
applications. But yes, no, this is definitely something that, for many reasons, Silica is something that's related to cloud technology,
Hmm.
the writing process, and I think we'll get back to that perhaps later in
Yeah,
our discussion. But
yeah.
yeah, definitely not something for the home.
How powerful is the microscope that you have to use to read this incredibly small written data?
It's a fairly straightforward from a power point of view, but it has been engineered to be high speed, high quality,
Hmm.
and under complete computer control. That enables us to move rapidly around the piece of glass to wherever the data is of interest, and then image at high speed to get the data back out.
Yeah. Well, so as you describe it, these amazingly tiny laser pulses store zettabytes of data. Talk for 1 second, still technically, about how you find and extract the data. You know, I've used this analogy before, but at the end of the movie, Indiana Jones, the Ark of the Covenant is stored in an army warehouse and the camera pulls back and there's just box after box after crate. It's like, you'll never find it. Once you've written and stored the data, how do you go about finding it?
So, like all storage media, whether it be hard drive, tape, the flash that might be in your phone in your pocket, there are standard indexing methods. There's an addressing system, blocks and sectors and tracks, and we use all of these kind of standard terminology in terms of the way we lay the data out on the glass, and then each piece of glass is uniquely identified, and the glass is stored in the library. And actually, we've done some quite interesting work and novel work on the robotics that we use for handling and moving the pieces of glass in silica. It's interesting. Dexter is talking about being interested in robotics. We've done a whole bunch of new interesting robotics in silica because we wanted the shelving or the library system that we keep the glass on to last as long as the glass. And so we wanted it to be completely passive, and we wanted all of the kind of the active components to be in the robotics. So we have these new robots that we call shuttles that can kind of climb around the library and retrieve the bits of glass that are needed and take them to a reader whenever reading is needed. And that enables us really to scale out a library to enormous scale over many decades or centuries, and to just keep growing a completely passive library.
Yeah, I saw a video of the retrieval and it reminded me of those old-fashioned ladders in libraries where you scoot along and you're on the wall of books, and this is sort of like the wall of glass. So, Richard, part two. Let's talk about silica from a practical point of view, because apparently not all data is equal, and silica isn't for everyone's data all the time. So who are you making this for, generally speaking, and why? And did you have aliens on your bingo card when you first started?
So no, I didn't have aliens on the bingo card when I first started, definitely not. But as I mentioned, yeah, Project Silica is really about archival data. So that's data that needs to be kept for many years or longer, where it's going to be accessed infrequently. And when you do need to access it, you don't need it back instantaneously. And there's actually a huge and increasing amount of data that fits those criteria and growing really very rapidly. Of course, it's not the kind of data that you keep in your pocket, but there is a huge amount of it. A lot of archival records that in the past might have been generated and kept on paper, they're now in the modern world, they're all born digital. And we want to look for a low cost and low environment footprint way of really keeping it in that digital format for the length of time that it needs to be kept. And so Silica is really for data that's kept in the cloud, not the pocket or the home or the business. Today, most organizations already use the cloud for their digital data to get advantages of cost, sustainability, efficiency, reliability, availability, geographic redundancy, and so on. And Silica is definitely designed for that use case. So archival data in the cloud, data that needs to be kept for a long time period, and there's huge quantities of it, and it's pouring in every day.
So, concrete example, financial data, medical data. I mean, what kinds of verticals or sectors would find this most useful?
Yeah, so the financial industry, there's a lot of regulatory requirements to keep data. Obviously, in the healthcare situation, there's a lot of general record keeping, any archives, museums, and so on that exist today. We see a lot of growth in things like the extractive industries. Any kind of mining, you want to keep really good records of what it was that you did underground or did to the earth. The media and entertainment industry is one where they create a lot of content that needs to be kept for long time periods. We see scientific research studies with it measure and accumulate a large quantity of data that they want to keep for future analysis, possibly use it later in training ML models or just for future analysis. Sometimes that data can't be reproduced. It represents a measurement of the Earth at some point, and then things have changed, and it wouldn't be possible to go back and recapture that data.
Right.
We see stuff in government and local government. One example is we see some local governments who want essentially to create a digital twin of their city. And so when new buildings are being built, they want to keep the blueprints, the photographs of the construction site, all of the data about what was built from floor plans and everything else that would help not only emergency services, but just help the city in general to understand what's in its environment. And they want all of that to be kept while that building exists in their city. So there's lots and lots and lots of growing data that needs to be kept, sometimes for legal reasons, sometimes for practical reasons. Lots of it, really fast-growing tier within the data universe.
Yeah. Dexter, let's go back to you. On the Avenues website, it says the purpose of the Golden Record is to, as you mentioned before, represent humanity and Earth to potential extraterrestrial beings, encapsulating our existence through a collection of visuals and sounds. That's pretty similar to the first Golden Record's mission, but yours is also different in many ways. So talk about what's new with this version, not just the medium, but how you're going about putting things together, both conceptually and technically.
Yeah, so that's a great question. I can take it in a million different directions. I'll start by just saying, of course, the new technology that Dr. Black is working on is like the biggest change, at least in my view, because I like this kind of stuff. But that's like really the huge thing: durability, longevity, and capacity. Capacity being one of the main aspects. We could just fit so much more content than was possible 50 years ago. But there's a lot more. So on the original Golden Record, they only had weeks to work on the project before it had to be ready to go to put on the Voyager 1 and 2 spacecrafts. So they had a huge time constraint, which of course we don't have now. We've got as much time as we need. And then I'll talk about how we've been working on the project. So we split up into two main teams: content and form. Form being media, which like I said earlier, is the team that I work on. And our content team has been going through loads of websites and online databases, which is another huge difference. When they created the original Golden Record 50 years ago, they actually had to look through books and like photocopy each image they wanted. Of course, now we don't have to do that. We just find them online and drag and drop them into a folder. So there's that aspect, which makes it so much easier to compile so much content and good quality content that is ethically sourced. So we can find big databases that are okay with giving us their data. Diversity is another big aspect that we've been thinking about. The original Golden Record team didn't have a lot of time to really focus on diversity and capturing everything, the whole image of what we are, which is something that we've really been working on. We're trying to get a lot of different perspectives and cover really everything there is to cover, which is why we actually have a online submission platform on our website where any random person can take an image of their cat that they like or an image of their house or whatever it may be, and they can submit that and it will make its way into the content and actually be part of the Golden Record that we hopefully sent to space.
Right. So, originally, like you say, there's a sense of curation that has to happen. I know that originally they chose not to include war or conflict or anything that might potentially scare or frighten any intelligence that found it, saying, hey, we're not those people. But I know you've had a little bit different thinking about that. Tell us about it.
Yeah, so that's something that we've talked about a lot, whether or not we should include good and bad. It's funny, I actually wrote some of my college essays about that, so I have a lot to say about it. I'll just give you my point of view, and I think most of my team shares the same point of view. We should really capture who we are with the fullest picture that we can without leaving anything out. One of the main reasons that I feel that way is what might be good to us could be bad to extraterrestrials. So I just don't think it's worth it to exclude something if we don't even know how it's perceived to someone else.
Mm-hmm. So back to the space limitations, are you having to make choices for limiting your data, or are you just sort of saying, let's put everything on?
So on the original Golden Record, of course, they really meticulously curated everything that went on the record because there wasn't that much space.
Yeah.
So they had to be very careful with what they thought was worth it or not. Now that we have so much space, it seems worth it just to include everything that we can include, because maybe they see something that we don't see from an image.
Right.
The one thing that we, at the very beginning during my J term in 11th grade, we were actually lucky enough to have John Lomberg, one of the members of the original team, come in to talk to us a bit. And he gave us a sort of a lesson about how to choose images. And he was actually the one that chose a lot of the images for the original record.
Mm.
So it was really insightful. One thing we talked a lot about was like shadows. A shadow could be very confusing and sort of mess up how they perceive the image. But it also might just be worth including because why not? We can include it and maybe they get something, they learn about shadows from it, even though it's confusing. So that's sort of how we have thought about it.
Well, that's an interesting segue because, Richard, at this point, I usually ask what could possibly go wrong if you got everything right. And there are some things that you think, okay, we don't know. Even on Earth, we have different opinions about different things, and who knows what any other intelligence might think or see or interpret. But I want to steer away from that question because when we talked earlier, Richard, I was intrigued by something you said, and I want you to talk about it here. I'll kind of paraphrase, but you basically said, even if there's no intelligent life outside our planet, this is a worthwhile exercise for us as humans. Why'd you say that?
Well, I had two answers to that. One selfish and one altruistic. I talked to a lot of archival data users, and those who are serious about keeping their data for many hundreds of years, they think about the problem in kind of three buckets. So one is the keeping of the bits themselves. And of course, that's what we are working on in Project Silica and what Silica is really excellent at. One is the metadata or index that records what is stored, where it's stored, and so on. And that's really the provenance or the remit of the archivist as curator. And then the third is really ensuring that there's an understanding of how to read the media that persists to those future generations who will want to read it. And this is sometimes called the Rosetta Stone problem. And that isn't the core expertise of me or my team. But the Golden Record kind of proves that it can be solved. Obviously, humanity isn't going to give up on microscopes. But if we can explain to extraterrestrials how they would go about reading a silica platter, then it should be pretty obvious that we can explain to our human descendants how to do so. The altruistic reason is that I think encouraging humanity to reflect on itself, where we are, the challenges ahead for us as a species here on planet Earth, this is a good time to think those thoughts. And any time capsule, and in the Golden Record, you can kind of view it a bit like a time capsule. It's a good time to step back and think those philosophical thoughts.
Dexter, do you have any thoughts? I know that Dr. Black has kind of taken the lead on that, but I wonder if you've given any thought to that yourself.
Yeah, we've given a lot of thought to that. Even if the record doesn't reach extraterrestrials, is it worth it? Why are we doing this? And we feel the exact same as Dr. Black. It's so worth it just for us to reflect on where we are and how we can improve what we've done in the past and what we can do in the future. It's like Dr. Black said, it's a great exercise for us to do. And it's exciting. One of the beautiful parts about this project is that there's no like right or wrong answer. Everyone has a different perspective on it.
Yeah.
And I think this is a great way to think about that.
Yeah. So Dexter, I always ask my collaborators where their project is on the spectrum from lab to life. But this research is a bit different from some of the other projects we've featured. What is the sort of remit of your timeline? Is there one for completing the record in any way? Who, if anyone, are you accountable to? And what are your options for getting it up into space once it's ready to go? Because there is no Voyager just imminently leaving right now, as I understand it. So talk a little bit about the scope from lab to life on this.
Yeah, so we, like you said, we don't really have an exact timeline. This is sort of one of those projects where we could compile content forever. There's always more content to get. There's always more perspectives to include. So I could do this forever. But I think the goal is to try and get all of the content and get everything ready within the next couple of years. As for who we're accountable to, we're sort of just accountable to ourselves. The way we've been working on this is not really like a club, I wouldn't say, more just like a passion project that a few students and a few teachers have taken a liking to, I guess. So we're just accountable to ourselves. We, of course, like we have meetings every week, and my teacher was the one that like organized the meeting. So I was sort of accountable to my teacher, but really just doing it for ourselves. As for getting it up into space, we have been talking a bit with the team led by Dr. Zhang. So ideally in the future, we would collaborate more with them and go find our ticket to space on a NASA spaceship. But there are, of course, other options that we've been looking at. There's a bunch of space agencies all around the world. So we're not just looking at the United States.
Well, there's also private space exploration.
Yeah, and there's also private space like SpaceX and et cetera. So we've thought about all of that, and we've been reaching out to other space agencies.
I love that ticket to outer space metaphor, but true, because there are constraints on what people can put on, although glass of this size would be pretty light.
I feel the same way. You do have to get like approved, like for the original golden record, they had to get everything approved to make it to space.
Right.
But I would think that it would be pretty reasonable given the technology is just a piece of glass essentially, and it's quite small, the smallest it could be really. I would think that there wouldn't be too much trouble with that.
So that does lead to a question kind of about then extracting, and you've addressed this before by kind of saying if the intelligence that it gets to is sophisticated enough, they'll probably have a microscope. But I'm assuming you won't include a microscope. You just send the glass?
Yeah, so on the original record, they actually included I'm not sure what it's called, but the device that you need to
a phonograph?
Play a phonograph, yes. So they included, they included a phonograph on the original Voyagers, and we've thought about that. It would probably be too difficult to include an actual microscope, but something that I've been working on is instructions on not exactly how to make the microscope that you would need, but just to explain you're going to need a microscope and you're going to need to play around with it. One of the assumptions that we've made is that they will be curious and advanced. I mean, to actually retrieve the data, they would need to catch a spaceship out of the sky as it flies past them,
right?
And which we can't do at the moment. So we're assuming that they're more advanced than us, curious, and would put a lot of time into it. Time and effort.
Yeah, I always find it interesting that we always assume they're smarter than us or more advanced than us. Maybe they're not. Maybe it's the gods must be crazy and they find a computer and they start banging it on a rock. Who knows? Richard, setting aside any assumptions that this golden record on glass makes it into space and assuming that they could catch it and figure it out, Silica's main mission is much more terrestrial in nature. And part of that, as I understand it, is informing the next generation of cloud infrastructure. So if you could talk for a minute about the vision for the future of digital storage, particularly in terms of sustainability, and what role Silica may play in helping huge data centers on this planet be more efficient and maybe even environmentally friendly.
Yes, absolutely. So Microsoft is passionate about improving the sustainability of our operations, including data storage. So today, archival data uses tape or hard drives, but those have a lifetime of only a few years, and they need to be continually replaced over the lifetime of the data. And that contributes to the costs both in manufacture and it contributes to e-waste. And of course, those media also consume electricity during their lifetime, either keeping them spinning or in the careful air conditioning that's required to preserve tape. And so the transformative advantage of Silica is really in the durability of the data permanently stored in the glass. And this allows us to move from costs, whatever way you think about cost, either money or energy or a sustainability cost, move from costs that are based on the lifetime of the data to costs that are based on the operations that are done to the data, because the glass doesn't really need any cost while it's just sitting there, while it's doing nothing. And that's a standout change in the way we can think about keeping archival data, because it moves from a continual, as it were, monthly cost associated with keeping the thing over and over and over, to, yeah, you have to pay to write it. If you need to read the data, you have to pay the cost to read the data. But in the meantime, there's no cost to just keeping it around in case you need it. And that's a big change. And so actually analysis suggests that Silica should be about a factor of 10 better for sustainability over archival time periods for archival data.
And I would imagine space is a good proof of concept for how durable and how long you expect it to be able to last and be retrieved. Well,
absolutely. Dexter mentioned the original golden record had to get a kind of approval to be considered spaceworthy. In fact, the windows on spacecraft that we use today are made of fused silica glass. So the fused silica glass is already considered spaceworthy. That's a problem that's already solved. And, it is known to be very robust and to survive the rigors of outer space.
Yeah. And the large data center. Well, Dexter, you're embarking on the next journey in your life, heading off to university this fall. What are you going to be studying, and how are you going to keep going with Avenue's golden record once you're at college, because you don't have any teachers or groups or whatever?
Yeah, that's a great question. So like I said, I plan to major in robotics engineering. That's still, I guess, like TBD. I might do mechanical engineering, but I'm definitely leaning more towards robotics. And as for the project, I definitely want to continue work on the project. That's something I've made very clear to my team. Like you said, I won't have a teacher there with me, but one of the teachers that works on the project was my physics teacher last year, and I've developed a very good relationship with him. I can say for sure that I'll continue to stay in touch with him, the rest of the team, and this project, which I'm super excited to be working on. And I think we sort of got past the big first hump, which was like the hardest part. And I feel like it will be smooth sailing from here.
Do you think any self-imposed deadlines will help you close off the process? Because, I could see this going, well, I should ask another question. Are there other students at Avenues or any place else that are involved in this that haven't graduated yet?
Yes, there are a few of us. So last year when we were working on the project, there were only a handful of us. So it was me and my best friend, Arthur Wilson, who also graduated. There were 3 other students. One was a 9th grader and 2 were 10th graders. So they're all still working on the project. And there's one student from another campus that's still working very closely on the project. And we've actually been working on expanding our team within our community. So at the end of last year, we were working on finding other students that we thought would be a great fit for the project and trying to rope them into it. So we definitely want to continue to work on the project. And to answer your question from before about the deadlines, we like to set sort of smaller internal deadlines. That's something that we've gotten very used to. As for a long-term deadline, we haven't set one yet. It could be helpful to set a long-term deadline, because if we don't, we could just do the project forever.
Right.
We might never end because there's always more to add. But yeah, we do set smaller internal deadlines. So like get X amount of content done by this time, reach out to X number of space agencies, reach out to X number of whatever.
Mm-hmm. Yeah, it feels like there should be some kind of, enough is enough for this round. Otherwise, you're the artist who never puts enough paint on the canvas.
Yeah.
And
I really like what you said just now with like this round and next round. That's a very good way to look at it. Like Dr. Black said, he produced 2 platters for us already towards the end of my last school year. And I think that was a very good like first round and a good way to continue doing the project, where we work on the project and we get a lot of content done. And then we can say, let's let this be a great first draft or a great second draft for now. And we have that draft ready to go, but we can continue to work on it if we want to.
Well, the famous computer science tagline, shipping as a feature. So there's some element of let's get it out there, and then we can do the next iteration of upgrades and launch then. Well,
exactly.
Well, Richard, while most people don't put scientists and rock stars in the same bucket, Dexter isn't the first young person to admit being a little intimidated and even starstruck by an accomplished and well-known researcher. But some students aren't bold enough to cold email someone like you and ask for words of wisdom. So now that we've got you on the show, as we close, perhaps you could voluntarily share some encouraging words or direction to the next generation of students who are interested in making the next generation of technologies. So I'll let you have the last word.
Oh, probably a couple of small things to say. First of all, researchers are just people too, and they like others to talk to them occasionally, and usually they like opportunities to be passionate about their research and to communicate the exciting things that they're doing. So don't be put off. It's quite reasonable to talk. I'm really excited by the kind of the passion and imagination that I see in some of the young people around today, and Dexter and his colleagues are an example of that. Advice to them would be, work on a technology that excites you, and in particular something that if you were successful, it would have a big impact on our world, and that should give you a kind of motivation and a path to having impact.
What you just said reminded me of a Saturday Night Live skit with Christopher Walken. It's the More Cowbell skit, but he says, we're just like other people. We put our pants on one leg at a time, but once our pants are on, we make gold records. I think that's funny right there. Richard and Dexter, thank you so much for coming on and sharing this project with us today on Collaborators. Really had fun.
Yeah, thank you so much for having us.
Thank you.